Okay, I think we can start. Hello everybody. Today we're going back to the theme of the architecture of Cascadeur. We'll be looking in the insights of Cascadeur today, and specifically today we'll be talking about how rigging works in Cascadeur from the technology side. Like how is it really made? What language we use to like write the scripts, the code, etc. I wanna to also ask you not to be shy. If somebody comes to our Discord chat, then you can ask your questions via voice chat. And if not, you can ask in the comment section or in the chat for streams. I will also be answering the questions about today's topic on the fly, but all the questions that are not related to today's topic I will answer in the end of the stream. Okay, so now let's first go over the main topics we will cover today. I will first talk about rigging in Cascadeur in general, and I will talk about the rig tool and the rig generator, which are like the main big parts of Cascadeur rigging. Then I will go into the details about the rigging tool, and specifically what parts are made in C++ and what parts are made in Python. And then, of course, the Python parts can be changed, basically by anybody who wants. Then I will talk about how rig tool actually works, what it consists of, what are rig elements or prototypes or proto objects in the rig tool, and then.
Sasha, one moment. You have forgot stream in Discord.
Oh, sorry. Yeah, sure. Okay. Okay, so now everything should be good. Then I'll cover the JSON format. That is actually basically that's what the rig tool serializes all the information about the rig into. And then I'll move on to the rig generation. What goes as an input to the rig generator, and what are the main steps of generating the rig. And then I'll finish just overviewing the whole process, how the rig mode is turned on and off, how the rig data, how the rig animation data, how they are saved. Okay, so now let's start. First with rigging in Cascadeur. Okay, I'll just open a scene. For now I will open a rigged scene. So basically you can see the character and you can see what the scene consists of. And it has, in Outliner we can see all the objects, and we have the armature, pelvis, etc, etc. These are all objects along with these meshes that were imported from the FBX file, and they will also be exported out of the program once you've done the animation. So you can export them back into the FBX. And the other thing that is present here is the rig. So the rig are objects that were generated inside Cascadeur, and you can see that there are like many types of objects here in the rig. It is pretty complicated. So there are triangles, rigid bodies, there are the rig info basically holds the information about the rig. There are points, which are the main point controllers, and yeah, of course, these objects are basically just like container objects that we have all the real working objects childed to. So they just don't hang in the, like, you know, connected to the rig. They're all sorted in the catalogs. Okay, edges. I think this is pretty obvious. Here you can see the edges I select. Centers of mass, boxes. There are sometimes IK splines and root constraints. So that's basically all the types of the rig objects that are there. And you can see that there is a lot of them. So how do they get created? Let's open a new scene and actually import NFBX model. For example, this DAS model. And because I have a new version, it has a typo, but we wanted to like simplify the process, and it actually asks me, do I want to open the rig mode? So when I just import the scene, I am still in the what we call an animation mode, and whenever I import a model, we now will ask if you want to enter the rig mode. I will say no for now. This is a feature that arrived like yesterday, so I don't want to risk as I'm on the stream right now. So I will manually go to the rig mode, and right now you can see that there is no rig. Obviously, it's only the joints and the meshes. So I go to the rig mode. It puts this window on, saying that yeah, some data will be lost if you regenerate the rig. But I have no rig, so I'm not afraid of this. Okay, I get into the rig mode, and I can see now basically the tracks and the frames are gone, and I can see the rigging tool. And in this rigging tool, I will like edit. I will edit the rig, and you can also see here animation info, which is during the rig mode. This is an object that actually holds some storage, holds some connection to the animation that was before I entered rig mode. Some data is here, some data is actually outside of it, like in the C++ code, stored, for example, the joints positions, etc. But we will get back to it. Now let's look at the rigging tool. So the rigging tool is basically this tab, and it has a lot of buttons, a lot of settings, and all of these buttons and settings, basically what they do is they create what we call rig elements or proto objects. So for example, I can select a couple of joints and click add rig element, and this rig element will be created. You can see the additional point is at the x-axis, which is not pretty good, so I'll just Ctrl Z. By the way, I'll make the box larger because it was so small we couldn't even see it, and I'll select the z-axis, and this is a global axis. Okay, add rig element, and now this is the additional point is positioned correctly, and you can see the box controller, which is still called box, although now it is a rectangle. So what actually happened? And now we're kind of getting to this, yeah, and let me just, so I follow my own plan, just cover this, this part that will actually let us create this proto objects is what we call the rig tool. So it creates proto objects, it can serialize them, deserialize them. We'll talk about what that means a bit later. And then using the information that was set by the user about this proto objects, then the rig generation tool will actually generate the rig. Let me just show it. I can go out of the rig mode. So here in the rig mode, I could, for example, okay, let me add another rig element, add a big one. And for example, I can see that I don't know, this additional point is not long enough. I want it to be like outside the mesh. So I can take it and actually move it, and it will stretch. I can actually move even this part, and it will not move the joints, because this is not a rig. This is basically proxy objects for the rig that will later be used to generate the information how the rig is structured. So we have information about what does this point, this rig element, when actually the rig will be generated, what joint it is connected to, and it will control this joint. And then we have information on how large this box controller or rectangle controllers are, so I can enlarge them, make them larger. For example, I want this larger, this smaller, and then I can also change the weight of the mass of the rigid bodies. I can change how they are connected. So all the stuff can be defined here, and then when I exit the rig mode, the information about the rig will be passed to the rig generator, and the rig generator will actually generate the rig. And now this is a true rig. I can actually move it, and you can see the character will move. I don't know. I can try to drag it, but it won't drag. But for example, this one, if I drag, it will drag the character. Although I can drag with this one. If you go here and put effect parent, then I will be able to affect with this point the parent. Okay, now suppose I don't like how this point is. I can go back to the rig mode, and when I go back to the rig mode, all the objects actually of the real rig, they're deleted, and then this proto objects are created. This proxy objects, I can change them, and I can go back. Okay, this is not actually an error. So you can see that now it is different, and it still controls the joints. So now I think I've covered the general idea. Let's go in more detail. Again, we won't, of course, go too deep into the code. I just want to show that this code is actually there, and how it is connected, at least what folders correspond to what tools, what code does what. So yeah. So all these buttons actually, they are written in QML and C++, but the actions that we actually press here, like create mirror object, add rig element, etc., these are basically just some settings that are read from here and then passed to the Python code, which is situated here. Okay, let me go. And this code is actually accessible for everyone. So if you installed Cascadeur, you have your own folder where you will see this code. And in this code, what we have are these different folders. And rig mode is the folder where the scripts that actually activate and deactivate and kind of bind together the rig tool and the rig generation. Those kinds of commands work are situated here. So on is basically turning on the rig mode, off is turning off the rig mode, and the rig tool itself is not in the folder rig tool, but instead in the folder that is called prototypes. This is not ideal, of course, but still, like historical reasons, so actually the code that is called once you like press any buttons here is situated there. So for example, add rig element is probably here, add rig elements action, and here we have the actions. and here we have add manual. Okay, add manual point is not the same. There are actually a lot of stuff, but I think here is the create product components, like the main one, and it actually, when you click on it, it actually creates all these components, this code. It's large, it's not ideal, to be honest. We didn't polish it as much as, for example, regeneration, although regeneration is still not ideally polished. But when you press it, basically a method out of here is called, and it creates all the objects. And let's actually look at the objects that the rig tool creates. So if you look here in the outliner, you'll see basically just two objects: the proto union hip and the proto union abdomen upper. Sorry for my pronunciation. So, but there's actually more objects. They're just hidden by default, so you can, you know, shift the hierarchy of the proto objects without having to think. By the way, proto objects is an old name. We hope to rename all this stuff to rig elements in the future, because proto, proxy, those are hard words to understand probably. And there are different settings here that you can change. But if you go here and show prototypes and press show prototypes inner objects, you'll actually see that there are more objects here belonging to this hip, for example. So there's the rigid body, which you can actually additionally move, I think. There's the direction point. There's the box that you can scale and move, and it will remember how it is positioned. So basically, all these objects, when you move or modify them, this basically affects how the objects after that in the generated rig will correspond to each other, how they will be, what their local positions will be. Okay, and the additional point, of course. You can also move it, and once you generate the rig, it will remember its position. So there are like a bunch of different actions. I think we have tutorials, different tutorials that cover them. But for example, let me just show that this stuff is present in the code. So when I press create mirror object, here, this mirror actions, you can see it's pretty straightforward. Create mirror is called, and there's a big action that does a lot of stuff, searches for the mirror joints, and creates the needed proto components. And that's not all the code, of course. There's much more here. Okay. So that's basically it. And yeah, I think I more or less covered this. I don't think we have to dive deeper into what different stuff resides here, what different code is here, but I do want to cover one more thing, and that is, what does this tool actually output? So this tool can import and it has import and export buttons. They were called import and export to JSON. It is still exported to JSON format, but now we have a different file type for it, .recasc, so it will be just easier to, you know, figure out what which files are actually the Cascadeur rigs and which are not. So I can save it. Okay, I will just replace it. Let me just go back here, and I'll open it with Visual Studio Code, which I prefer to use for the JSON files. And so you can see here. Okay, let me close that. You can see here the JSON file. It is actually pretty big, but you can see that most of its content is inside joins local data, because the rig automatically, like when you enter rigging mode, if you don't have any rigs in the scene, it automatically thinks that all the joins that are present in the scene belong to the rig, and it saves all the data of the local data of the joins, because this is basically, usually when you enter the rig, this is the T-pose and you want to save it for future use. So it starts here. All the join data except the joins that are actually covered as the units, their data is stored here as the rig units that have the rig units connected to them. And so here you can see this units. And we have a very strange way of writing them. So you have the main joint that it's connected to and the path to the joint. So this Genesis 8 mail hip is basically, it's this unit that is connected to this, but to this joint. So, and you can see a bunch of different data that is stored there. So it's the like base global offset. This is the offset of the point from the joint. Okay, the box position. This is the offset of the box. You can see box orientation, so you can set a custom orientation offset of the box. Okay, I will open. And then box scale that was set up, rigid body offset, the mass of the rigid body, which was set to 10, etc., etc. So all the settings, all the positions, all the information about the positions of the additional point, etc., all of them are stored here in this JSON. And we also have this abdomen upper, which is the next joint that is covered and connected to a rig element. And that's all the rig elements there are there in the file. So, okay. And basically, this JSON is something that gets like, this is the API, the output of what the rig tool produces. So you can actually, so the rig tool, its API is like, you can bring the JSON in, and it can generate proto objects, and you will have a state where you have the proto objects that basically describe the rig. You can edit them, and then with the help of the rig tool you can export like the JSON data, the data about the rig. You can export it to JSON, or you can pass it on. I think there's also like a Python representation of this data, but it is easy to serialize Python data representation, and you can pass it to the rig tool. To the rig generator. So that's what it does. And and what I started with is that it can actually generate the prototype. So let me delete this, and of course the deletion is also something that is in the code. So I will delete it, and now I will import it from the proto rig cask, and it generates the prototypes. So that's basically how it is. You can so the rig tool knows how to generate these prototypes, and it can actually, you can import prototypes for parts of the rig, which was done to like rig a weapon once and then reuse this rig in different scenes. So okay, that's how it works. Okay. Maybe there are any questions, by the way. We've passed like half of the stream, I think.
No, I didn't see any questions that I will didn't able to answer in chat.
Okay.
None for me, but great stream so far.
Okay. Thank you. Thank you. Thank you for the support. So okay, let's move on to the rig generator. And here, okay. The first thing I want to say is pretty trivial. So what is the input into the rig generator? Well, it's basically all this data that we saw in the JSON format. Plus, of course, it's the actual real objects, the joins themselves. And the rig generator, what it does is it actually creates the real objects, the real control objects that are then used by the animator to animate. Yeah, one more thing, the last thing I wanted to cover here is that, well, potentially, although it's not possible, at least yet, to change this rigging tool, to change the user interface, it is basically possible to change, for example, the method that adds the rig element and adds some new behaviors to this proto object that, for example, will tell the rig generator in the future to actually create some floating objects. I don't know, to just put a pivot in them or do something else. So that is basically possible, and it's also possible. All the process of creating the JSON is also inside Python. I think it's here, the JSON actions, and it's probably this JSON export. So it serializes proteins to string, and potentially, although of course it's really hard, I doubt anybody at this point will try to go this deep, but potentially all of this can be changed and new objects added, new functionality added, and then that can be added inside the JSON, and this data will be passed to the rig generator after you switch off. So actually we can even see what this off function does. So it creates remembers the rig properties, like the mirror plane of the rig that is used later for inside the mirroring tool. It deletes the proto objects once it read all the properties, created the JSON, etc. It deletes the proto objects, and then it generates the rig. And again, potentially this data can be passed then here to the rig generator, which is called here generate rig. And then there are some additional stuff like, okay, returning cycles, restoring some data that is usually deleted when you enter the rig mode. Okay, so here we have the generate rig function, and we'll just look at it at the very basic level. So here this is called rig context, and inside it has like rig generator scene context, and inside we're already in the modify method, so we're modifying the scene, and we have access, and we just store all these different editors that help you actually change the model, like the behavior editor, the model editor, the update editor, etc. So, and the viewers, they're all here, and then we start to generate the basic structure of the rig. So first we create the rig context, and here we actually calculate different properties, read all the data from the JSON, create some Python objects that will later be used to be filled with the actually generated real objects inside Cascadeur. So there's like a layer of, like there's the scene, like in Cascadeur, and then there is this Python that has different references to the scene that allow you to change the scene. And here inside the Python virtual environment, you have different objects you create, and there are structures that actually are used when the generation is done. So, for example, there's this rig context, and you can actually see that there's the unit context, and then this rig units, they are sorted in different ways. There are centers of mass, composite centers of mass, etc. IK splines, root constraints. So this is like a big, it appeared, I think, in Python 3.8, what's called a data class that actually holds a bunch of datas, and they're kind of typed. Python has dynamic typing, but with this you can actually show to the programmer what types these objects will have. Okay, so after this rig context, let me go back. After we created rig context, we generate different standard objects. First, the boxes, which are now rectangles. Then we create the points. I think this is pretty obvious. So the boxes, the points, and then we generate the rigid bodies. We tune joints because sometimes we have to change something in the joints during the recreation process. And then all of this is actually in this, let me show this file, it's here, it's inside the rig generation. Then we create objects that are used to connect like other various objects, simple objects like the centers of mass that use the rigid bodies mainly, but they're also actually connected, for example, to the pole vectors, to the direction controllers. Then we create here the root constraints, and for some reason we create spline IKs at the very end, although I think we should in the future move them up a bit. And then we connect different objects. So these objects are created, and we have to create like the whole hierarchy, otherwise you can't connect. They're connected in different ways, like the 3 points are connected to one box, etc. And we have to create the whole hierarchy, and when everything is already ready, then we connect the objects between each other. So we connect points, box, boxes and joints. Then we connect, oh yeah, rig elements. Not a very nice name, but let's look what's inside. Yeah, here we connect the pole vectors, the direction controllers, to the centers of mass. Otherwise, direction controllers are regarded as parts of the point rig, because they are basically very strongly interconnected to the points. They define the points define them. So they're parts of the points rig. And then we connect. There are special behaviors that say which objects should lie on one track, and then we connect this connect rig to layers of joints. So it basically connects these objects and puts objects to the right tracks. Tracks and layers are basically the same. Okay, and so the finishing part is here, which basically just creates the rig info that holds actually the information about the rig. Okay, hides secondary behaviors, etc. So, don't know why this is called rig mode off. Maybe that's a mistake. So that's basically it. That's how the rig gets generated, and then we get the whole rig that functions. One more thing I wanted to cover here is that it is not ready yet, but I was actually hoping in the future to separate. It is actually I found out that it's harder to do than I expected, but potentially this parts of the rig, like the boxes and the points, they're basically, they can function theoretically on their own. For example, boxes are mainly like, they're just like joints, but they don't have the scale, so they're orthogonal, what we call orthogonal transforms, based on orthogonal transforms, and they're connected to the joints. So potentially you could just create this new, something like an FK rig hierarchy, and then you can control it, and it will move the joints, and if you move the joints, they will move. And then we could create the points, and the points could be created and moved and animated themselves, like without being connected to anybody, just having the points, and then even without the rigid bodies. And then we could add rigid bodies. Yeah, rigid bodies probably can't exist without the points, because points hold some of the behaviors that connect the rigid bodies together, but that's why they're created after the points. But these two are basically separate. This one depends on the points, and yeah, the joints are just tuned, they're not connected to anything. Then of course the objects like the centers of mass and the root constraints, they're dependent on other objects, and then we just connect the systems with each other. So when you move the point, the box moves, etc. So okay, now I think let's move on to the finishing part, and that's how the rig and animation data are saved. I have a tipper here too. So the rig and the I've already said, I think, that this object rig info, if it's not shown here, but actually if I open the node editor, I'll be able to see that here in the rig info there is a field that's called product.json, and it doesn't reference to any data. It is a string field. We have fields like that. They're not shown here. The value is not shown here, and that's a good thing, because it would be very big, because that's basically just this JSON that is saved in this object. serialized, and whenever we press enter rig mode, everything is deleted, but this data is used to create the product components. So that's how the information about the rig is stored. And then the information about the animation, because we can like add new keys. Turn on interpolation, and you can see that the character is animated, and I can then enter rig mode, and all the objects are actually deleted. And when I exit the rig mode, you can see that the animation is still in place. So how it gets saved? Well, basically the information about the animation of the joints is saved, and it's held in the C++ part, although I think the data gets read in Python. So in Python code we read all the data of the joints, of all the local values, like translation, rotation, scale, and we store it, and basically we apply it is identical to the fact that we would copy interval and paste interval. So the rig is created, and then the data of the joints is copied, pasted, and applied, and it updates the rig. So actually when I go to rig mode and out of it, if I, for example, change something, for example, let me change the position of this point. Now I exit rig mode, and you can see that although this point now its direction is here, the animation on the joints is actually saved. Okay, it's not a very nice animation, but still the positions of the joints are the same, and actually even writes you an error if they are not, or at least a warning. But the position of this direction is different. So what the tool tries to save are the positions of the joints. And of course, if your rig is different, for example, you didn't have a direction controller, the pole vector, and now you add a pole vector and you have some interpolation here, then where there's interpolation, the interpolation will be different, because now the pole vector will be used if it's the IK interpolation instead of the positions of the points. So you can get a pretty different animation, but not too different, and the keys will mostly be saved, unless you have some constraints that are now that now change and don't allow your joints to be positioned like that. Okay, so that's how the data is saved. And I think, just because I do have some time, I just want to go again, kinda like considering, try to draw a picture to just visualize how this all works. So you have like the animation mode and the rigging mode. Just write rig for shortness. And in animation mode you have controllers like points, rigid bodies, etc. And you have the the tracks with the animation, and of course you have the joints. The joints will be present on both sides, and when you enter the rig mode, the controllers get deleted, and the JSON that was kept in the rig info object, if there is a rig, the JSON is used to generate JSON, and of course the joins, JSON and the joins, because it is used to generate the proto objects, and they are actually bound to the real joins that are in the scene. And so you enter this rig mode where you have the proto objects, and you don't have the animation. The animation is saved for joins. Here you have the proto objects, you still have the joins, and then when you press, you can change something in the proto objects, and when you press animation mode, it will first kind of go and generate the JSON data. Okay, it might be in the, in the way it will look like Python classes that are hold all the information, but it's basically the JSON data, the same JSON data, and it actually does generate the JSON. So the rig info is stored in the JSON format in the rig info object, and now the protos are deleted, and this information about the rig is used to generate the controllers. Okay, so that's basically how all the system works. I'm thinking whether or not it's a good idea to cover the like the inner parts of this rigging system, because I doubt somebody will go try changing something in it. Although, again, potentially all this is possible, and I hope that someday we will polish it enough, and like, I don't know, somebody actually like the community will actually start to change and create their own scripts and maybe change the rigging process, and maybe we can think about a GitHub repository to actually have branches there for the community that will then add to the main build, or not add if they don't want to. Maybe they can create them and, I don't know, sell them. But I think this is a bit far away. So yeah, but for today, this is it. And okay, now I think let's talk a bit more about the future streams. So we still have a lot of ideas about implementing different stuff that you asked for in the Discord. We also have ideas of actually covering most interesting questions that were asked in the Discord channel, and maybe we will invite somebody to participate in our streams. So these are the main ideas for now. Yeah, if you have any other ideas or maybe topics I could cover, I'm not able to cover any topics like regarding creating the animation, because the animation will be very bad, like much worse than all the people who participate in the Discord in the streams. They can animate much better than me, so that will be a sad thing. But you, if you're interested like in the technical part or how some of the tools work, etc., I could cover any of that. And yeah, and we do have some ideas to actually. I think this one is out right now, but we have like other ideas of what we could cover regarding the rigging process. But I think that we can like enlarge it maybe to some tool usage and how the tools work technically, etc. Although most of it is covered in our tutorials, but maybe you have some like more complicated questions. I would be happy to answer them. And if you have your own ideas, please write them in the chat, or say them if you're in the voice chat, or write them in the comments below. We read all of the sources and we'll take them into account. Okay? So Ilya, are there any questions? I see you.
No. And for this moment, I didn't saw any questions more.
Okay. So it seems like the pinnacle of the technical streams where like everybody, okay, most of the people fallen asleep, and but that's okay. But I think it's hard to ask questions about today's topic, and we try to answer Discord questions. Okay. So if there are no questions, then thank you guys for coming. And I think we can today stop. And then next week, I think we'll go back to the dev blog format, and I'll cover what was actually done inside by our development team. Inside, I mean like in-house. Okay, thank you guys for participating. Bye.
Thanks, bye.